Hey y'all, welcome back. Today we're going to be learning about permutations and combinations. I really enjoy permutations and combinations. They help with counting the number of possibilities that are possible for different events. Um, and we'll be using them in probability in this class. All right. So the first thing we need to talk about before we learn about permutations and combinations is factorial, because both permutations and combinations use factorial. So a factorial is the product of all positive integers less than or equal to a given number. So n factorial is n times n minus 1 times n minus 2 all the way until we get to 1. So times 1. All right, we'll look at a couple examples over here with actual numbers. So we have 3 factorial. We're multiplying all the integers less than or equal to 3. So that's 3 times 2 times 1, which is 6. 5 factorial is 5 times 4 times 3 times 2 times 1. That's 20 times 3 is 60 times 2 is 120 times 1 is still 120. All right. Now we're going to learn about permutations and combinations. So before we start, I'm going to write a note underneath each. For permutations, order matters. And for combinations, order does not matter. So before we take our notes, I want you to imagine that you have 9 cards on a table and they're listed 1 through 9. All right, each one's numbered 1. Well, each one has a number, and those numbers are 1 through 9. And you want to draw a 3 and then a 5 and then a 7. So you want your first draw to be a 3, your second draw to be a 5, your third draw to be a 7. That would be a permutation because the order that you draw those cards matters. You want your first draw to be a 3. All right? Combination would be if we draw 3 cards and then look at them and just hope that we have a 3, 5, and 7 in our hand. It doesn't matter if the 3 was drawn first or second or third. It doesn't matter if the 5 was drawn first or second or third, or same for the 7. All right, so there's going to be a lot more possibilities with the permutation where the order matters. So I'm going to give you the formula for permutation, then we'll look at the example of drawing a 3, then a 5, and a 7. All right, so permutation is NPR. All right, so the number of total cards that we have, and then the number of total cards that we are drawing. All right, and the formula is n factorial over n minus r factorial. All right, so n is the total number, r is the number we pick. Okay. So looking at the example of drawing a 3 and then a 5 and then a 7. So there are 9 cards, we said. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9, P, and then we're drawing 3. Okay. So that's going to equal 9 factorial over n minus r, which is 9 minus 3 factorial. And so this is 9 factorial over 6 factorial. Now, what's cool about factorial is 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So the 6 factorial is going to cancel out with the 6 factorial from the 9 factorial. And all we're left with is 9 times 8 times 7. Okay? So 9, because that first draw there was 9 cards to pick from. 8 because that second draw there was 8 cards to pick from, and 7 because that third draw there was 7 cards to pick from. And 9 times 8 times 7, that gives us 504 possibilities. Okay? Now, if I want to know the probability of drawing a 3 and then a 5 and then a 7, that's one of those 504 possibilities. Okay? Now let's see how that compares to a combination. So a combination, the order does not matter. And so that's going to be in CR, and that is n factorial over n minus r factorial divided by, or times r factorial. Now, the reason for this is because the order doesn't matter, we have to also divide out the different possibilities that gave us the 3, the 5, the 7 in our hand. All right, so again, n is the total number, r is the number we choose. Okay, so this is same thing, it's 9, choose 3. And that's 9 factorial over 9 minus 3 factorial times 3 factorial. Okay, so again, we have 9 times 8 times 7 because the 6 factorial comes out of the 9 factorial, but we still have a 3 factorial. So this is divided by 3 times 2 times 1. So then when we do that math, we have that same 504, but now the 504 is being divided by 6 because 3 times 2 times 1 is 6. And that gives us 84. So the probability of having a 3, 5, 7 where the order does not matter would be 1 out of 84. Okay, we'll look at a couple more worked examples, and then there's some problems for you to try. So the first worked example, 10 contestants enter a singing competition. How many ways can first, second, and third place be chosen? So we have 10 contestants. The order matters because first, second, and third, they're different positions. So the order matters. So this is a permutation. And we're choosing 3. So that's 10 factorial over 10 minus 3 factorial, just 10 factorial over 7 factorial. So we have 10 times 9 times 8 because the 7 factorial cancel out from both. And that is 720 possible combinations. All right. For number 2, there are 8 dogs in the shelter and your family wants to adopt 2 dogs. How many combinations of 2 dogs exist? So this is a combination because the order does not matter. Doesn't matter which dog you chose first, both of those dogs are coming home with you. So in this case, we have 8 choose 2, and that's 8 factorial divided by 8 minus 2 factorial times 2 factorial, which is going to be 8 factorial over 6 factorial times 2 factorial, which is 8 times 7 over 2 times 1, which gives us, oh no, yeah, 28 combinations. Okay. There are 2 problems here for you to try. Good luck.